So let me share your webcam, Srivalli. Here it is. So I will stop sharing. So Srivalli, first, thanks to be part of it, of the PAC today. And
Thank you.
I've looked at the slides, and you'll see it's going to be really, really awesome. So I think it's one of my favorite presentation of the day. So I will leave you present yourself, present your talk and everything, and I will get back to you afterward for the Q&A session. Enjoy.
Okay, yeah, thank you. Let me just start sharing my screen. Oops.
We are
You know
still.
when you're.
I don't see. Yes, I don't see the slides yet. We were seeing your desktop a few seconds ago.
Oh, okay. Let me know if you're able to see now.
It's perfect.
Okay, cool. So, okay, thank you, Henrik. Thank you for the wonderful opportunity. And Kiara, good morning, good afternoon, good evening, everyone. Like Henrik already mentioned, my name is Srivalli Aparna. I'm from Auckland, New Zealand. So I'm currently working as a senior test consultant for the testing consultancy here in New Zealand. So I think I have been in performance testing space for most part of my 10-year career, mostly in consultancy background, but with the exception of one product company, of course. So yeah, with that introduction about myself, I'll just get started on my presentation for today. Okay. Production like test environment. I'm pretty sure every performance tester at some point would have heard or used this phrase, production like performance test environment. We all know why it is important to have a production like environment for performance testing, because the closer an environment is to the production in terms of scale and configuration, the more meaningful and accurate the test results will be. I mean, what's the point in performance testing a system if the results don't say anything about how it's going to perform after go live, right? This is why setting up a realistic performance test environment is a key prerequisite for performance testing. Yet, most of us would have been in a situation where we ran a test, we found a performance defect and reported it with all these pretty and colorful charts. And then the dev or infrastructure team pushes back the issue saying, you know what, it's just an environment issue. Don't worry about it. It'll never happen in production. So these sort of environment issues, as trivial as they may sound, they can be really costly when it comes to performance testing because they can lead to false positives or false negatives in our test results. I mean, I always mix up the definitions between false positives and false negatives. But anyway, the idea is you could have one situation where you run a test and all your test results are fantastic and the transactions are running under a second and your code goes live and everything starts to fall apart. Obviously, you missed a major performance defect. Or the other type of scenario is what I have mentioned earlier, like you ran a test, you reported an issue and you're all excited about it, and then it turns out to be an environment issue. So none of these are ideal situations to be in, right? And could have potentially been avoided by setting up a proper performance test environment. So the goal of my presentation today is to present with some tips or best practices you can call, basically the things that need to be considered while setting up your database ready for performance testing. So just to be clear, the focus is not so much on performance tuning a database because that's a vast topic and that's for another time. But today's presentation is more about setting up realistic performance test databases to get more meaningful and accurate test results. I'm not pretending to be a database administrator or a database expert here, but these are the things that I have learned working closely with some of the best database experts in my career. I'll be using Oracle database as a reference throughout my presentation because that's what I'm familiar with working for Oracle. But these concepts are equally relevant for most of the relational database technologies. Okay, so well, hopefully by now we all sort of agree why it is important to have a production-like environment for performance testing. I guess the question is now, how do we do it, right? How do we make sure that our test environment is production-like? Well, fortunately, it's pretty simple. 2 steps, okay? Step 1, get your number of CPU cores, RAM size, disk space, operating system version for your production servers as well as your performance test servers, and then do a quick comparison, okay? Step 2, if they are sized equally, then yay, just go ahead and start our load tests. No. Well, no. I mean, my point is, comparing hardware specs is just not enough to ensure that an environment is fit for performance testing. Especially when it comes to databases, there are more things to consider. Because the same SQL query can perform very differently in 2 different environments in spite of having the same hardware specs in both the environments. But why is that? So this is where things start to get really interesting. So every database has a component called optimizer. So optimizer is essentially like your brain of the database. Okay. So typically, when you issue a SQL statement to your database, you tell your database what to do, but not how to do. Well, there are some exceptions, but most of the time, you let your optimizer determine the most efficient way to execute your SQL statement. At a very high level, this is how it works. Like when you issue a query, your optimizer generates not just one execution plan, but a number of possible execution plans for your query. And then it associates cost with each of the generated plans and chooses the one with minimum cost, which is what we call an optimal plan. So there are a lot of factors that influence the decisions made by the optimizer while coming up an optimal plan for your query. So I think it's really important for us performance testers to understand how this works so that we don't accidentally influence the optimizer's decisions. So I will cover each of these factors that influence your query performance and optimizer behavior in detail in further slides. So the first factor I want to talk about today is the quantity of data. So it's the data volume, the amount of data present in your database. This one probably doesn't need a lot of explanation because the more data present in your database, the more work your database has to do. So the slower the queries tend to be. So let's take a simple example to put things into perspective. Okay, so there are 2 environments, environment 1 and 2. So in each of these environments, we have a table called employee. And in environment 1, employee table has only 100 records. But in environment 2, we have 100,000 records in the table. So assuming everything else is the same for a moment, all the indexes and everything else is the same. So say if your application is looking for an employee or a set of employees, so it issues a query like say, select first name, last name, email address from employee table where first name is like John. So if the same query runs in these 2 environments, it is likely to take longer to process in the second environment than in the first environment. Why? Because say let's just assume for a moment that there are no indexes and your optimizer chose to do a full table scan. In that case, in environment 1, so a full table scan is nothing but reading each and every record of the table from the disk and then eliminating the ones it doesn't need. So in the first environment, it has only 100 records to fetch from the disk, whereas in the second environment, it has obviously more records to fetch from the disk. So I'm I mean, I'm consciously skipping some technical details here because data is read in terms of blocks and not records. And I'm ignoring any caching effects and things like that. But the point is, if you have more records to process, to fetch from the disk and process, so it means more physical disk and CPU activity in your database, which means longer processing times. Even if there is an index on this table here, so the index size tend to be relatively larger in environment to support larger data volumes, which means your query has to traverse through multiple levels to get to the desired record here. So I mean, okay, this is a very basic example. I know. The difference in the query execution times may not mean much in this example like this with one table, but in the real world, queries are much more complex. They involve a lot of joins and a lot of tables. So then this difference will become much more obvious. So, okay, by now you all must be thinking, okay, we get it, data volumes are important. So what do we do about it? Well, I think the first step is to understand what are the current data volumes in our test environment, and then do a comparison with the volumes in production. So I will show in my demonstration at the end of presentation how to get this information. So in Oracle, you can query something like db underscore segments view to get this information. Or you can always do a simple select count star on the tables to get the number of records and do a quick comparison. So that should give us a fair idea on where we are standing in terms of data volumes in our test environment. So if the numbers are close enough, then we are good. And if they are not, we probably have a couple of options here. Either do an export from the production and then import the data volumes into your test environment. If you're not able to do it for security reasons or whatever, then probably you need to create your own bulk insert scripts or populate the test data using your load testing scripts. So with that, I will move on to my next point. So the next factor that influences your query performance in an environment is the nature of the test data. So it's not always about the quantity, it's not always about the amount of data present in the database. So the nature of the test data matters too. And so this factor becomes much more relevant and important if you are artificially pumping up your data volumes in your test database using your load testing scripts or by any other means. So when you do that, when you artificially inflate the test data, it is really important to make sure that things like data uniqueness and the data distribution are what we call cardinality in technical terms is realistic. So the technical textbook definition of cardinality is the number of rows returned by each operation in an execution plan. So I just want to show a simple example what I mean by cardinality. So for example, I have run a so for this query here, I just did an explain plan in a SQL developer, and you can see it generates a column called cardinality, and it shows, okay, these are the estimated number of records that your database will need to fetch for this specific operation. So yeah, anyway, I was just curious whether this cardinality estimate was right or not, and then I did a simple select count star, and it is actually right. So interestingly, this cardinality is a huge factor when your optimizer makes its decisions, because the amount of work that needs to be done by your optimizer is proportional to the number of records that it needs to fetch and process. So whether your column has a lot of unique values or a lot of repeated values, so that determines the number of records that need to be fetched by an operation in your query execution. And this cardinality drives a lot of key decisions during your query execution, something like what join method do I use, or what join order, which table should I pick up first while driving the join, or what access method, do I go for a full table scan or do I do an index scan? So a lot of decisions made by your optimizer are closely tied up to this piece of information. And there are obviously a lot of ways incorrectly loaded test data can skew your performance test results. So I want to talk about an example now. So again, let's take two different environments, environment 1 and 2. So this time we have a customer table in these two environments. So in the first environment, in both the environments, we have 100,000 customer records in it. So the data volumes are same, but what's difference is that, as you can see in the first environment, there are like probably roughly about 20% of customers with outstanding payment. Whereas in the second environment, we have probably about like 80% of customers with outstanding payment. Okay, so now if you issue a query like, okay, select customer details from customer table where payment status equals to outstanding, something like that. So if the same query runs in the two different environments, what your optimizer might look at the data in the first environment and think, okay, I just need 20% of the records. So okay, that's my cardinality, 20% of the records. So maybe I can just do an index scan. I mean, assuming there is an index. So because index scan is efficient, less physical disk access, and much faster, so it might go ahead and do an index scan. But when your optimizer looks in the environment 2, might look at the data and think, okay, I need 80% of data, so that's a lot of data. It might be cheaper to do a full table scan, although there is an index, because when your database does a full table scan, it can do much larger IOs compared to an index scan. So it is cheaper to do fewer number of larger IO calls than doing a lot of smaller IO calls, because you can minimize the number of trips made to the disk in the first case. So it might just go ahead and do a full table scan. I mean, this is a very, very basic example. So, but my point is, your environment 1 could be your test environment, or environment 2 here could be your production environment, or it could very well be the other way around. So it doesn't matter which environment is what, because your query is performing differently in these two environments. So your test results may not mean much in terms of what will happen in production. So that's why the data distribution is a really key factor when you're setting up your test data ready for performance testing. So it is, in my demonstration today, I will like quickly give a small example how to get this information from the table. But I think at the end of the day, it's a good idea to make sure that things like, okay, number of nulls in a column and number of distinct values, unique values in a column, and the skewness, the distribution of these data. So all these things are realistic in your test environment. So that influences your query performance and your test results. Okay, so that finishes my second point, and let's move on to my third factor that influences your query performance in an environment. Okay, so optimizer stats. Optimizer stats are nothing but a collection of data that describe the information about your database and the objects present in your database. So these statistics are used by your query optimizer to choose the best possible execution plan for your SQL statement. I mean, so what's present in this stats? So it has a lot of information, a lot of technical information. It has information about your tables. It has information about your columns, your indexes, and your system IO, CPU information. So your optimizers uses this information to come up with an execution plan. So, I mean, okay, well, this information is already present in your database, right? And your optimizer knows where to look for and what to do with it. Why do we even need to worry about it? Well, we need to, because the objects in the database are like constantly changing. Your data in the database is constantly changing all the time. So these statistics must be regularly updated so that they accurately reflect the information about your database. So stale statistics can impact your optimizer's cardinality estimates big time. Like we have already discussed in the previous slides, right? How crucial cardinality estimates are for your query performance. So, okay, having said that, there could be plenty of scenarios. Although you have updated stats, your optimizer might be having wrong cardinality estimates, but that's a real performance issue and that needs to be fixing. That's a different scenario. But what I'm talking about is we don't want to be the reason why your optimizer has incorrect cardinality estimates. So if I quickly go back to the previous slide for a moment, say there is a table, customer table, which has 20% of customers with outstanding payment. But the data in the table has changed over time, and now the same table has 80% of customers with outstanding payment. So if you haven't updated your stats since then, your optimizer might still be thinking that, okay, I still have 20% records with outstanding payment. So it might do something which it thinks is efficient, but which is not. Or let's take another example where, say, when your database is doing a join. So when it does a join, say between two tables, it takes the smallest of the two tables, and then for each of the record in your smaller table, it keeps probing the larger table. So that way it can minimize the number of probings, minimize the activity it is doing. But if your stats are not up to date, it could end up picking up a wrong table to drive the join, so which could completely compromise your query performance. Well, the real world is much more complex than this, but my point is, like, I hope these examples are scary enough for us to remind about the significance of stats next time we run our load tests. So why take chance? I mean, let's just make sure that stats are up to date before we run our test. Hopefully, in the real world, in production, you will have an automated stats job set up to run, which collects these stats, say once in a day or two, depending on the schedule, right? But just make sure that this automated stats gathering is in place in your test environment as well. So even if automated stats is in place in your test environment, it is still a good idea to manually gather stats before your test run, in two scenarios I could think of. First scenario is when you have done a lot of bulk inserts or updates as part of your test data preparation. Then it's definitely a good idea to collect stats after your preparation. The second scenario is if you're running a lot of back-to-back peak load tests and stress tests within the same day, then your data is changing at an accelerating pace. So even then, it's a good idea to collect stats between the test runs so that you get consistency in the test results. So at the end of my presentation, I will quickly demonstrate where to look for if you want to know when a specific table was analyzed the last time, or how to manually gather stats. So I will do a quick demonstration at the end of my presentation. So the fourth point I want to talk about today is the database parameters. So every database has a lot of parameters that are configured at the time of initialization of your database. While it may or may not be practical to compare all these settings between your test and your production environment, it is still worth doing a quick check between the key settings that could impact your query performance to make sure that the settings are consistent between the environment. So in taking Oracle database as an example, there are some parameters that we need to check to make sure that they are set appropriate in your test environment. So I don't want to talk about like each and every parameter and its significance. That will be too boring. But at a high level, let's just understand why these are important. Okay, first about memory parameters. So we all know that physical disk access is expensive, it's slow, it's costly, and memory access is much more faster than disk access, right? So for this reason, your database stores some stuff in memory so that it can minimize the disk access. So the things that are stored in memory could be anything. It could be anything like recently read data blocks, or recently modified data blocks, or could be like recently executed plans, or even your database could have a portion of memory that is dedicated to support large sort and merge operations, things like that. So if any of these parameters are set lower in your test environment or are set different than in your production, you will start seeing a higher disk activity and CPU activity. So that will lead to slow performing queries in your test environment. which will ultimately impact your performance test results. So it doesn't matter even if the RAM size is same between your test and your production servers, but if your memory parameters are set differently, you will see a completely different performance for your queries. Similarly, there are other bunch of parameters for parallel processing. So these settings, parallel processing, they influence the parallel execution of your query. So parallel execution is a key aspect, especially for large-scale data processing applications. So the benefit of parallel processing feature is that it helps your database take advantage of all the hardware resources available, like multiple CPUs, multiple IOs, multiple storage systems, etc. So making sure that these parameters are set consistently between your test and production environments is definitely a good idea. So the final point I want to slightly touch upon before I move on to the demonstration part is about indexes. I mean, we all know why indexes are in place and how they speed up the process of finding a record in a table. So yeah, I don't want to talk about that stuff, but um, I personally didn't have an experience where some indexes are missing in the test environment, which were supposed to be in place. But apparently, when I was talking to my colleague the other day, he said it happens more often than we think. So, so it doesn't harm. So it's probably a good idea, best practice to make sure that all the indexes are in place in your test environment, which were supposed to be there, so which are already there in production. So I will demonstrate how to look for this piece of information in my demo today. Well, I guess that's enough of me talking. My throat hurts, and I will shortly move on to the demonstration bit. But hopefully, doing all these checks and thinking about all these aspects of database will help us avoid false performance issues and helps us focus on real performance issues instead. As well as I hope this helps us understand our test environment and our test databases better instead of treating them just like a black box. So yeah, with that, I will quickly bring up my SQL Plus for the demonstration bit. Okay, I'm just connecting as SSDBA because I already have access to, but you probably don't need DBA level access. You could run it with any user as long as you have select any table privilege for these queries, which I'm running now. Okay, so the first point, if you remember today, we discussed 5 different factors that we need to check in the test environment. So the first one was checking the data volumes, right? So for that, you can run a query something like this. Information is in bytes, so I'll convert it into MB just for presentation. From DBA underscore segments, that's the view we are interested in, where owner is the schema name. So I'm interested in a couple of schemas. Card. So I know this is a very basic example because this is just a sample schema and I don't have a lot of data in it. But so by querying DB underscore segments view, I can at least, it's a starting point for me to say, okay, what are my schema sizes in the test environment? So you may or may not be able to run the same queries depending on the access restrictions in production, but probably you can get this information from your DBA for production servers and just do a quick comparison. But this is at a high level. It doesn't tell you what tables are having data or what tables are not having data. For that, we can use a slightly different view, which I will talk about it when I'm talking about optimizers in a minute. So optimizer stats in a minute. So the second factor we discussed is about how to make sure that the data distribution is consistent between your production and test environment. So for that, I will write a query. So just to give a bit of context, this HR schema has a table called employees. So it has a number of employees who are associated with a department. So now the query which I'm running now is to see how many distinct departments are present and what is the distribution of employees across those departments. So for that, department ID and count star as employee count from HR dot employees group by department. I mean, yeah, this is very basic query, but in the real world, you might need to write a little bit more complex query, joining more than one table. But as you can see, we have different departments here, and there are a different number of employees associated with each department. So it's not a uniform distribution, right? Some departments have more employees than the others. So it is important to make sure that it doesn't have to be exactly the same, but as long as you get the distribution more or less right, then your query performance should be fine. And the third factor we talked about today is about optimizer stats. So for that, let me just, I just want to check how many records are present in my employees table first. Okay, we have 142 records in our employee table, but if I query my most analyzed rows DBA tables. I can't talk and type at the same time, but oops. Okay. So this is a DB underscore tables is one of the views which shows when was a table last analyzed. So as you can see, the last time stats were gathered on the table was yesterday, and it says that it has employee table has only 130 records, but when in fact it has 142 records, because since I've made changes to the table, I've inserted new records, but I haven't updated the stats. So that's why I'm manually gathering stats now. Miss underscore stats package is what we use. Gather schema. That's name. It's the schema name is HR. Okay. So oops, there is a typo. Exec dbms underscores. Oh, sorry, it's dbms. Gather schema. Hopefully it should name HR. Okay. Now if I check my, so now stats are updated and it shows the last analyzed column is 6th June today, and the number of records are updated. So I mean, I have gathered stats for the whole schema, but you can do for just a table or column, and there are some advanced options as well for gathering schemas. For skew columns, you take a slightly different way, things like that. So but this should give us a starting point. And the fourth thing which we discussed about is about initialization parameters. It's quite straightforward. So there are a lot of parameters which I've already exported to Notepad++ for easily viewing. So this shows a list of parameters that are set in their current values. So I mean, if you see any discrepancy between these settings, between test and production environment, I still wouldn't recommend changing these values by yourself. It's still a good idea to work with DBA, because when you change some values, some settings needs a restart to take effect. So I wouldn't recommend it. So the final thing which I want to quickly show is where to look for the list of indexes in the test environment. Will name from DBA underscore indexes. Here, owner is again HR. So this view shows the list of indexes and the list of tables on which the indexes are present. I forgot to mention something. Let me just quickly go up for a moment, or I'll just do. You can use when we're talking about db underscore tables, right? So this has the number of rows column. So you can use this information to do a comparison for the data volumes at a table level, which will be quite handy. But before using any of these views, just make sure that the stats are up to date so that you get most recent information. So that's what I have today, pretty much. Thank you for your patience. And yeah, if you have any questions, just let me know.
All right. Thank you, Srivalli. So I see that we have Thomas Roti that is connected. So I'm just going to enable his webcam so he can be part also of our Q&A session.
I think that yes.
And also there is other pack members available here today. So Ruby, for example, which is will be the first speaker of the Chinese and Indian region. Ruby, I will also enable your webcam if you're ready, of course. And if you have any questions, I will ask you later on if you need to drop your questions, Ruby. So let me know, Ruby, if you have any questions as well. Same thing for Ramya. Ramya, I've enabled your webcam, so you can also interact with us. I will enable Srivalli's webcam. And we have also, oh, Stephen is there.
Yeah, I have a special guest here.
Awesome. So Thomas, I'm going to enable your webcam. So before we start the Q&A session, I had noted again a lot of questions. I know, I'm paying. You were referring about the hardware specifications. So, so first, before you do any testing activities, do you recommend any like sort of a checklist? So you mentioned first look at if the number of records, the number of bytes per tables are aligned with is properly aligned with your testing environment. That's so the testing database, the stats. So are you doing like a sort of a checklist before you start load testing, and then once if the checklist is being properly answered, you can go ahead, or if not, you have an action plan afterward with the DBA, for example?
Yeah, that's correct. That's exactly right. So all these things which I've mentioned today are pretty much the prerequisite before even you get started on load testing. I mean, you don't want to be in a situation where you know, I know it's always stressful that you need to start testing as soon as possible, but you can't skip this prerequisites. I mean, if you do, then you are probably wasting clients' times as well as everyone's time later. So yeah, this is definitely the first point to first step before you proceed with your load testing.
Okay, and then you mentioned about the hardware specification. So imagine that in my production I have a huge database, but the storage is stored on a, let's say network disk file or whatever it is. And in my testing environment, I don't have that, so it's like a global storage. So once you discover those differences, do you recommend the project to say, could we change the architecture, or if not, how can you make the proper conclusion? Because that's the big challenge.
Yeah, I agree. I mean, again, always the preference would be to make the test environment as close to as production possible. But if that is not possible, too costly to do, or then we probably have to work around it. And I mean, at least we know when something goes wrong, we know if it is because of that issue. Okay, we know that, okay, we are expecting that issue. We can probably isolate those timings for that latency and things like that. We can work around. It's not easy, but at least when we know it beforehand, we can make sense of the results better. Instead of freaking out as soon as we see high timings in the test environment, we can. Yeah, it needs extra work, to be honest. But if that is what we need to do, we have to work with it.
Okay. The other thing, and this is also something I'm trying to make a project understand. Usually, when you have a testing environment where you have a scenario that will create users or creating, I don't know, customers, usually to make it easier to sort of remove the fake data that we're creating, we all every time we rename it like perf user one, perf user two, or customer perf or whatever the name, but there is always the same prefix. And you mentioned about it.
Yes.
The thing is, in your application, if you create a fake user and then you log in, I guess there's a query to get the privilege, the user rights of that user. So I guess you mentioned about the index, and you said about the customer that has a problem, issue of payment issues. I think here it's the same thing, I guess. Would you recommend to avoid creating testing data that has always the same prefix, or what would be
Yeah.
your recommendation?
Yeah, I think so. Yeah, it's definitely a good idea not to prefix all your users with the same, perf test or something, because the thing is, I mean, I can't tell for sure how exactly your optimizer might think at that point, but one scenario I could think of is like, you know, it could impact your cardinality estimates again, because same prefix, if you I don't know, at some point if you are doing any query like I mean, I have scenarios where when we create not just user but any test data, if you prefix with something and later if you're searching for it with only portion of it, like, and then you're searching like percentage per percentage, you are essentially having different different number of results in your search, right? So that will definitely skew your estimates, cardinality estimates. Yeah. Yeah, I wouldn't recommend doing it. Yeah,
Stephen,
that's
could,
a
could you
problem.
could you repeat the question because you were very far?
Oh,
Sorry. I was just saying that I've seen the opposite where there's too much unique data that also can skew.
Yeah, I
that's
think
a
I mean
problem too.
so usually what happens also if especially if you always update the same, I don't know, let's say we have a company within that, so there is several organizations in the table, and like you mentioned with the HR, with the department, let's say you always pointing to the same department and you're doing all the same updates, and suddenly do the load test and you say, oh my god, there's a big problem on database, you look at that query. But because maybe the fact that you're always putting the same department ID, whatever it is, maybe you're locking all those users trying to write on the same thing,
Yes,
so you're
same.
observing a
Yeah.
block which never appears
Yes.
in production. So
Yeah,
data sets
exactly. Yeah.
is really important for sure.
Yeah, that's true. Yeah.
And another thing that you mentioned was uh, so about the parameters. So I guess depending on the parameters of the database, if you have two different environments and the parameters are not there, would you try to force try to recommend to change the settings of the database to be exactly aligned to make sure that the testing context is exactly the same that we have in production, or yep.
Yeah, I mean, so the context I'm talking here is because the nature of the work which I do is when I work for a client, they most of the time they have the application in production already, but they are making new changes, new features, and releasing it. So in that context, if you are setting up your test environment, I would recommend changing the parameters to match with the production, so that. But there could be completely different scenario, like especially if you're working in a product company, you don't want to match it. I mean, that's a different approach altogether. So anything which you set up in the test environment is like a trial and error, or your best settings from your the database provider or things like that, and then you play around with it, and then you see what works best, and then you apply that changes to the production. So there are different approaches depending on your nature of work, I guess.
So, all right, thanks, Srivalli. Thomas and Frederick, do you have any questions for Srivalli's presentation?
Are we on? Hello, can you hear us?
Yeah,
hi. We can hear you well.
I can hear you.
Hello. Good morning. Hello, good morning. No, we thought it was very interesting, especially the part when you say you should see that you are actually testing the real life environment. That I thought was very interesting. But no, looks very logical to me.
Yep. Thank you so much.
I have one last question. It's all about GDPR, because you're taking a production database, and then obviously now because things have changed with the GDPR regulations, now you're not able to take the same data within our testing environments. So once you have anonymized the data with GDPR, are you also redoing those checklists to say, okay, if the anonymization causes differences between my production, or do you also do that type of validation?
No. Sorry, I didn't quite get the question. No, sorry.
So with GDPR now, sensitive data that could be collected from production needs to be anonymized. You're not able to.
Oh, okay. I didn't have that situation. Okay. Yeah.
So, but I guess after you have anonymized the data, you will have to sort of validate that we still align with the same in the same context that we observed in production, I guess.
Yeah, I guess that sounds logical to me. Yeah.
Okay. All right. So thanks, Srivalli, for your time and your presentation. It was really interesting.